Bismillahir Rahmanir Rahim. Assalamu alaikum students. This is Hamza Noor, and in this particular video I'm going to solve a question from the topic differentiation, International A-Level Edexcel P4 January 2021, question number 6. A curve has equation 4y square plus 3x is equals to 6y times e raised to the power minus 2x. The requirement for part A is to find dy over dx in terms of x and y. So here we have an implicit function, okay, and we need to follow the procedure of implicit differentiation. Over here, implicit function is a function which is not expressed explicitly, which is not an explicit function, meaning y, it is not in the form of y equals fx. Okay, so this is an implicit function where a combination of y and x variables is given to you. All right, so what we are going to do, we are going to differentiate each and every term in this equation with respect to x. Okay, so we are going to differentiate 4y square with respect to x. Then we are going to differentiate 3x with respect to x, and then we are going to differentiate 6y times e raised to the power minus 2x with respect to x. So what you need to remember, the rule over here is that whenever the term in y, term which is related with the variable y, let it be algebraic, let it be trigonometric, exponential in the form of logs, or it is an inverse trigonometric function, any type of term which is related with y, which is related with y variable, which is given to you in terms of y, whenever it is differentiated with respect to x, so first it will be differentiated with respect to y, and then it will be multiplied by dy over dx. This concept is basically from the chain rule. If you need a derivative with respect to x of any term which is related with y variable, so first of all it will be differentiated with respect to y, because a term is itself in form of y. Okay, a term is itself in terms of y. So first of all, it will be differentiated with respect to y, and then it will be multiplied by dy over dx, so that according to the chain rule concept, you can get a derivative with respect to x. So, and I'm going to differentiate 4y square with respect to x. So first of all, it will be differentiated. It will be differentiated with respect to y. So when 4y square is differentiated with respect to y, it will give you 8y. And in order to get a derivative with respect to x, you have to multiply it with dy over dx. Then when 3x will be differentiated with respect to x, so it will be just simply 3. We don't need to multiply dy over dx in this case, because the term is uh, in terms of x. Okay, the variable is x over here. And then for this, these two terms are being multiplied over here. So in order to find a derivative of 6y times e raised to the power minus 2x with respect to x, we need to use the product rule over here. Okay, so I'm just doing some working in order to find the derivative of 6y times e raised to the power minus 2x with respect to x, and I'll do this working on the next page in this box. We are going to find the derivative of 6y times e raised to the power minus 2x with respect to x. So u is equals to 6y. So u dash is supposed to be 6 multiplied by dy over dx, because we need to differentiate each and every term with respect to x. And I've already explained the rule earlier. So v is equals to e raised to the power minus 2x. So v dash is supposed to be minus 2 multiplied by e raised to the power minus 2x. So when the equation is in the form of u times v, so the derivative is uv dash plus vu dash according to the product rule. So uv dash plus vu dash, so this will be 6y multiplied by minus 2 times e raised to the power minus 2x plus vu dash, this will be 6 times e raised to the power minus 2x multiplied by dy over dx. So I'm going to write this whole thing on the earlier page, on the previous page. So this will be minus 12 minus 12y e raised to the power minus 2x plus 6 e raised to the power minus 2x multiplied by dy over dx. So what we need to do, we need to just make dy over dx the subject of the equation over here, nothing else, so that we can actually find dy over dx in terms of x and y. So the terms which are related with dy over dx, as you can see, will be arranged on one side of the equation, and the terms which are not related to dy over dx will be arranged on the other side of the equation. So 8y multiplied by dy over dx minus 6e raised to the power minus 2x multiplied by dy over dx is equals to minus 12y e raised to the power minus 2x minus 3. So when you take dy over dx common, taking dy over dx is common, you are left with 8y minus 6e raised to the power minus 2x. And on the right hand side of the equation, you are left with minus 12y e raised to the power minus 2x and then minus 3. So therefore, all you need to do is just make dy over dx a subject of the equation. So therefore, dy over dx is equals to minus 12y e raised to the power minus 2x minus 3 and then divided by 8y minus 6 e raised to the power minus 2x. And as you can see that any particular form of dy over dx is not required over here. So yeah, you can leave your final answer like this. But if a proof is required, if it is required to prove that dy over dx is exactly in this form, in any particular form, then you need to follow all the steps and arrive at the final answer and arrive at that final proof, and then you will be able to secure full marks. But in this case, as any any specific form for dy over dx is not required, so yeah, you can leave this thing as your final answer. Then the information is, let me just erase this working and bring the question on this page. Okay, so the curve crosses the y-axis at the origin and at the point P. The curve crosses the y-axis at the origin and at the point P. Find the equation of the normal to the curve at point P, writing your answer in the form of y is equals to mx plus c, where m and c are constants. Okay, so as we know the fact that at the point P, the curve crosses the y-axis. Obviously, the x coordinate will be equal to 0. So we can say that the coordinate of P is in the form of 0 comma y. So when I keep x is equal to 0, I would be able to, I mean, if I keep x is equal to 0 into the dy over dx function, which we have obtained over here, we will get the gradient of the tangent. Okay, so but we also need to keep a corresponding value of y, because dy over dx is not only in terms of x, right? It is in terms of y as well. So first of all, what we need to make sure is that we need to put x is equals to 0 into the original equation of the curve, the original implicit function which is given to us in the question, so that we can find the corresponding y coordinate as well. So 4y square plus 3x, 4y square plus 3x is equals to 6y multiplied by e raised to the power minus 2x. So first of all, my intention would be to find the corresponding coordinate of y when x is equals to 0. So 4y square plus 3 times 0 is equals to 6y multiplied by e raised to the power minus 2 times 0. So 4y square is equals to, it will be just 6y, okay, because e raised to the power 0 will be 1. So 4y square minus 6y will be equal to 0. As I know the fact that the curve crosses a y-axis at the origin as well. So I'm going to get a value of y which will be equal to 0 in this case. And that will be the point of origin. But I would be interested in the other value of y which is other than 0, which and that value of y will tell me the y coordinate of the point P. As simple as that. So taking y as common, multiplied by 4y minus 6, and this whole thing is equal to 0. Therefore, y is equal to 0, and 4y minus 6 is equal to 0. So y is equal to 6 over 4, and 6 over 4 in its simplest form is 3 over 2. So y equals 3 over 2, which means that y is equal to 1.5. Now I can say that the coordinate of P is 0, comma 1.5, and the other point where the curve crosses the y-axis is the origin, which is 0, comma 0. Okay, this thing was very important to find the value of y, the y coordinate of the point P, because what you need to do, first of all, you need to find the gradient of the tangent at point P, so that actually by using the relationship of perpendicular lines, you can actually find the gradient of the normal. Okay, so what I'm going to do now, I'm going to find the gradient of tangent at point P, and point P is actually 0, comma 1.5. And in order to find the gradient of tangent, I'm going to use this dy over dx function, because the value of dy over dx at any particular point will give you the value of the gradient at that point. So dy over dx is how much? Dy over dx is minus 12 y e raised to the power minus 2x. Let me just write it over here. Dy over dx is equals to minus 12 y e raised to the power minus 2x minus 3, and then divided by 8y minus 6 e raised to the power minus 2x. Now in the dy over dx function, I'm going to put this coordinate, this point P, which is having the coordinates of 0, comma 1.5. So minus 12 times 1.5 multiplied by e raised to the power minus 2 times 0, then minus 3 upon 8 times 1.5 minus 6 e raised to the power minus 2 times 0. So as we know that e raised to the power 0 will be equal to 1. So minus 12 multiplied by 1.5, this is minus 18. So minus 18 minus 3 divided by 8 times 1.5 is what? 12, and minus 6. So the gradient of the tangent at the point P is supposed to be minus 18 minus 3 divided by 12 minus 6. This will be minus 7 over 2. This is the gradient of the tangent at the point P. Now I'm interested in finding the gradient of the normal, because I need the equation of the normal. And as we know that the tangent and the normal, these two lines are perpendicular to each other. Therefore, I can say that the gradient of tangent multiplied by gradient of normal is equals to minus 1. And as we know that the gradient of tangent is minus 7 over 2. So minus 7 over 2 multiplied by gradient of normal will be equals to minus 1. Therefore, the gradient of normal is supposed to be minus 2 divided by minus 7, which will be 2 over 7. So the gradient of normal is 2 over 7, and obviously that normal would be passing through the point P, which is 0, comma 1.5. So we need to find the equation of the normal in the form of y is equals to mx plus c. So the gradient of the line is 2 over 7, and the point is 0, comma 1.5. So y minus y1 is equals to m times x minus x1. So y minus 1.5 is equals to, the gradient is 2 over 7. So 2 over 7 multiplied by x minus 0. So y minus 1.5 is equals to 2 over 7x just, and y equals 2 over 7x plus 1.5, and 1.5 is actually 3 over 2. So y equals 2 over 7 multiplied by x plus 3 over 2. It is in the form of y is equals to mx plus c. Therefore, the gradient is 2 over 7, and c is, and as they are saying that where m and c are the constants to be found, so therefore m is equals to 2 over 7 and c equals 3 over 2. This is supposed to be your final answer. And this complete question is worth 9 marks. Thank you for watching. Assalamu alaikum.